Question number 3. Ethanol reacts with oxygen gas to produce carbon dioxide and water vapor. So this we see because carbon dioxide and water vapor produces, we know again, is a combustion reaction. These are spontaneous and they produce large amounts of heat, right? Let's look at the entropy change. So delta N is going to be positive 2, right? It goes from 3 moles to 5 moles. So there's going to be a positive entropy change. Therefore, work is also going to be done on the surroundings because delta work, remember, is negative delta N times RT. So if this is positive, so work is going to be negative. So work negative means work is going to be done on the surroundings. So let's do our first calculation. So the enthalpy change. So again, looking at the table, we're going to see that for water, it's going to be minus 241,282. For carbon dioxide, it's going to be minus 393. And for ethanol as a liquid, it's going to be 277,69. Again, remember the negative coefficients for the reactants, the positive coefficients for the products. And then we're going to get about minus 1234 kilojoules. Okay, let's calculate the bond energy. So the bond energy is a little bit more complicated this time because there's more bonds, right? So we're going to do the bonds broken minus bonds formed, right? The sum of the bonds broken minus the sum of the bonds formed. Okay, and so what bonds are going to be broken? So let's draw ethanol really quickly. So we're going to be breaking 5 CH bonds. 1, 2, 3, 4, 5. 1 CC bond right here. 1 CO bond. 1 OH bond. And 3 O double bonds to an O. And then we're going to subtract 4 because there's going to be 4 C double bond to an O bonds being formed. Okay, so there's 799, and then 6 OH bonds. So this is going to equal about minus 1258 kilojoules. Okay, and let's calculate the delta N of the gas. So we said earlier, from 3 moles of gas to 5 moles of gas, so there's going to be plus 2. So that means that the work is going to be delta, remember the negative, delta N RT. So remember R is 8.314 joules mole per Kelvin, per mole Kelvin. And then for temperature, we're going to use about 300. So this is going to give us an answer of about minus 5 kilojoules. Okay, and so let's do the next part. So the delta N of the system is now plus 2 because now we have to also include like the liquids, the solids. So here we have 4 moles becomes 5 moles, so it's going to be plus 1. 5 minus 4. Okay, let's calculate the delta S. So the delta S is the entropy. This again is just done by looking at the table. So for water, it's going to be 188. Similar calculation to enthalpy. Carbon dioxide minus ethanol is 160.7 and minus 3 oxygens, 205.14. this is going to give us about 217.85. Okay, if we want to calculate T delta S, that's going to be 300 kelvins times 217.85 joules per Kelvin. Let me put the units here. And so that's going to equal about 66 kilojoules. Okay, and so now we can calculate the delta G. What the values we calculate. So delta H equals about minus 1, 2, 3, 4, and then minus plus 66. So that's going to give us about negative 1,300 kilojoules. So again, this is a spontaneous reaction. Combustion reactions we know are spontaneous, so this agrees with what we predicted.